The easiest way to start using NVIDIA's Riva Speech AI SDK is to download the Riva Skills Quick Start resource folder from NGC. This provides scripts for downloading pre-trained models, deploying either pre-trained or customized models, and launching a server which you can access either locally or remotely for speech AI services. In this video, we'll download the resource folder from NGC, then edit the provided configuration script to download the models and deploy the services we need, run the initialization script to actually perform that download and deployment, and finally, launch the server. Now that the NGC CLI is configured, we can finally start our exploration of Riva. The first step in this is to download the Riva Skills Quick Start resource folder. You can find it pretty easily in the NGC catalog search bar, even if you don't narrow your search to resources first. Near the top right of NGC's page for the Riva Skills Quick Start resource folder, you'll see a download button. Click on that and select CLI from the drop-down menu. That will copy the NGC CLI command for downloading the latest version of this resource. The next step is to paste this command into your terminal and run it. Once the download command finishes running, you'll see a message printed to your console in the format you specified when running ngc config set. If the indicated download size isn't unreasonably small, you downloaded the asset successfully. And sure enough, this size is sensible. For the rest of this demo, I'll be using VS Code rather than a pure terminal. That way, I can use a terminal and a text editor simultaneously. Likewise, I've switched to my actual working environment, which I've already set up with my NVIDIA credentials. You've just downloaded version 2.10.0 of the Riva Skills Quick Start resource folder. The next step is to open the configuration shell script named config.sh, examine it, and modify it for your purposes. First, consider which Riva services you'd like to enable. Your choices are automatic speech recognition, natural language processing, speech synthesis, and neural machine translation. A complicated pipeline could conceivably involve all of these services. In that event, keep your eyes on your GPU's memory constraints. Some of these models are big, particularly for NMT. Let's start this part of the demo by only enabling ASR and TTS. We can return to the others later and edit the config script accordingly. Scrolling down, we come to a variable named Riva model lock. If the assigned path doesn't already exist, it will be created when you run the Riva initialization script, rivainit.sh. This directory will contain several subdirectories. One of these contains RMIR files, which are intermediate representations of models that are ready to deploy, but not yet fully optimized. When we pass this script, after having finished editing it, into the Riva init script, we'll be downloading several default pre-trained RMIR files. You can also generate RMIR files yourself by downloading NEMO models from NGC, customizing them as needed, exporting them to Riva, and then running the Riva build command. Another subdirectory, named models, is for model pipelines which have been optimized for deployment. The Riva init script generates these from the RMIR files present in the Riva model lock/RMIR directory. You can also use the Riva deploy command to build pipelines from RMIR files. I'm going to change Riva model lock to a location where I've already downloaded many of the default RMIR files. Next, I'm going to leave use existing RMIRs as false. This is because there's at least one default R mirror that I'd still like to download from NGC. Starting with the current version of Riva, namely 2.10.0, both the fast pitch and RAD-TTS MEL spectrogram generation models, each of which is coupled with a hi-fi GAN vocoder, are downloaded by default. Previously, only the fast pitch MEL spectrogram generator was available this way. Generally speaking, downloading both is unnecessary, if nothing else because of GPU memory constraints. Since I'm more familiar with fast pitch, let's comment out the lines that would download RAD-TTS. We've finished editing the Riva config script for the time being. Now, let's run the Riva init script. By default, Riva init.sh will use config.sh as its configuration file, so passing in the config script this way is not strictly necessary. However, it comes in handy if you have multiple configuration files for different applications. If you haven't downloaded your models already, this script can take a long time to run, particularly if you don't have a fast internet connection. Even optimizing R mirrors for deployment can take a while. All right, Riva init has finished running successfully. Now let's run Riva start. If all goes well, Riva server should start in less than a minute. And there we go. We've now launched Riva server with the default ASR and TTS models. You now know how to download the Riva Skills Quick Start resource folder from NGC, edit the provided configuration script to enable the services and download the models you need, run the initialization script to download and deploy the models, and start the Riva server with the start script. In the next video in this series, we'll begin exploring Riva's capabilities through the Riva Tutorials GitHub repo. You'll learn how to send requests to the Riva server and run inference with several pre-trained models. See you there.